Section 1.7, we're going to be looking at exponents. And we need to start off by actually defining what an exponent is. And so we see here this kind of new thing to our math notation, and we have a 3 with a little 4 up here. And that is called the exponent. So when we have 3 with a little 4 up there in the superscript, it's called, it simply means you're repeating the multiplication of 3 4 times. And so on your notes there, you can kind of write this in here. 3 is called the base. 4 is called the exponent, which means 3 is a repeated factor. Factors means multiplication. And the way that we read that is 3 to the 4th power. So when we see something over here like this, we read that as 3 to the 4th power. Now there are a couple special instances with exponents. A number squared has an exponent of 2. So when we see a 2 here, we can just say 5 squared instead of 5 to the second, although 5 to the second is still proper. And then if you have a 3 here in the exponent, we say cubed. So we could read that as 2 cubed, which means 2 is used as a factor 3 times. Again, it's also okay to say 2 to the 3rd power. So just to get us an idea of what's going on here, we have this exponent this here, and the way that we read that is we read that as 4 to the 2nd power, or what we just learned, we could say that's 4 squared. Then in expanded form, since we have 4 squared, that means 4 is a factor twice, so we have 4 times 4. And then if you simplify 4 times 4, you get 16. So we're going to kind of do the same thing for that one, try to think ahead a little bit. So in your notes, you can write down how you're supposed to read this, like in words. And we could read this as 6 cubed, which we mentioned if we have an exponent of 3, we can say cubed, or we can say 6 to the 3rd power. So that can go in your first blank. Expanded. Expanded means you want to write out what this means. And this means we want 6 multiplied by itself 3 times. So 6 times 6 times 6. And if you multiply that out, we have 6 times 6 is 36. We know that. And then we multiply by 6 again. We get 6 at the 3. 6 times 3 is 18 plus 3 is 21. So simplified is 216. Next one is similar. Let's take a look at this. This we have 1 as our base and 5 as the exponent. We can read this as 1 to the 5th power. There's really only one way to read that. There's no special thing like squared and cubed. In expanded form, that means we want 1 multiplied by itself 5 times. And that's nice and easy because we have 1 times 1 times 1 times 1 times 1, which is just 1. So simplified would just be 1. Next on your paper is a skill check. It says write the exponential form of each. Before we get there, I have a couple things. So this PowerPoint's a little bit different than the order of your notes. So if you flip your notes over, it says exponent rules. We will actually come back again. But it says a number with an exponent of 1 is equal to the number itself. So 3 to the 1st means 3 because it means 3 as a factor just once. So it's just 3. Or 27 as a factor just once. So just 27, or 865 to the 1st is simply 865. So now going back to the skill check, on your other page, now it says write the exponential form of each. 5 squared, So why don't you take a minute just to write the exponential form of each. You can pause the video and write those 4 answers. All right. 5 squared. Well, that's one of those special instances. 5 squared means you have 5 with an exponent of 2. Number 2, 9 cubed means you want 9 with an exponent of 3. Remember that cubed means 3. And then we have 6 as our base here. And we have that 1, 2, 3, 4 times, so 6 to the power of 4. And lastly, we have 3 as the base, and it looks like that's going to be 5 in the exponent, so 3 to the 5th. So hopefully you had that for your skill check. Moving forward, we've talked about the whole numbers already. The natural numbers are really just our counting numbers. That's how we count things. They occur naturally. So 1, 2, 3, 4, 5, 6, it keeps continuing on and on forever and ever. So those are the natural numbers. So moving on to the next page, we already talked about the first box. It says a number with an exponent of 1 is equal to the number itself. The next one, which is stated here, says a natural number raised to the 0 power equals 1. So that's an interesting one, but it is true and we use it all the time. It's nice and easy. Once you know it and makes it easy. So a natural number raised to the 0 power equals 1, which means 8 to the 0 power is 1, or 42 to the 0 power is 1, or 342 to the 0 power is 1, or we could have 2 plus 9 minus 3 times 5 to the 0 power. Well, it doesn't matter what's in here. It's to the 0 power, so it's equal to 1. So that's a good rule to remember. Next, 0 raised to a natural number power equals 0. So if you take 0 to a power, it always equals 0, which makes sense because 0 cubed means 0 times 0 times 0. Well, that's 0. And 0 to the 7th means you multiply 0 times itself 7 times, which is 0. I don't know why anyone would want to do that, but it's still 0. So 0 to any natural number is 0. So realize it says natural numbers, and the natural numbers start with 1, 2, 3, 4. So notice there's not 0 in here. And then the last rule we'll talk about in a second or so. So here's a couple examples, just trying to get us to realize what exponents, how they work. So 3 to the 4th, what does that equal to? Well, 3 to the 4th means that it's going to be 3 as a factor 4 times. So 3 times 3 times 3 times 3. And if you multiply that out, actually you can use the commutative property. 3 times 3 is 9. Times 3 times 3 is 9, and we know 9 times 9 is 81. So we get 81 for that first one. The next one's asked a little bit differently. It's saying 2 to what power gives us 32. So we're going to try to think through this a little bit. So let's just start working our way out. 2 times 2 is 4. Times another 2. No, that's 8. So we're not to 32 yet. We're trying to get to 32. Times another 2, that's 16. Times another 2, well, that is 32. That's what we want. So what's the question mark represent here? That represents a 5 because we have 1, 2, 3, 4, 5. So the question mark is a 5. There you have it again, underneath my writing. Finishing this off, 6 times 10 cubed. Well, 10 cubed, that's 10 times 10 times 10. We learned about that in a previous lesson, 10 times 10 times 10 should be just 1,000 because it has the 3 zeros. And then we want to multiply 6 times 1,000, which is 6,000. So that's how you do that one. So the question mark there would be 6,000. All right, take a look at that skill check. See if you can figure out what those things would be equal to. You can hit pause while you do those, and then we'll get back to it. All right, what did you get? 7 squared. Well, that's 7 times 7, which we should all know is 49. So that one's 49. Next one, we actually just mentioned this in the previous example. 10 cubed is 10 times 10 times 10, which you should get 1,000. Next one, 2 to the 4th. Well, that's 2 times 2 times 2 times 2. Really, when you do this, you should be able to work your way across. 2 times 2 is 4, times another 2 is 8. 8 times 2 is 16. So our answer is 16. And then the last one, 2 times 5 cubed. Now this one, we need to do the exponents first. So you have to be careful. Don't do 2 times 5 first and then cube your answer. You do 5 cubed first. So this is going to be 2 times 5 times 5 times 5. Well, the nice thing about this is, remember we can use the commutative property of multiplication. 2 times 5 is 10. And then 5 times 5 is 25. So just multiplying 25 times 10 is going to give us 250. And that is the section on exponents. The last thing that we need to mention, 0 to the 0 power, which it's up in your exponent rules in those boxes in your notes. It says the expression 0 to the 0 power is undefined. That means there's not an answer to that. So if you ever see 0 to 0, you can just write out the word undefined. And then example 2, write for, what is that? Well, here's your units, thousands, millions, billions, 4,205,090,006 by using expanded form with exponential notation. All right, well, we have 4 times a billion. Well, a billion would have 9 zeros. So instead of writing a billion, we can write 10 to the 9th, because 10 to the 9th would have 9 zeros. So plus, so this is going to make this a little bit shorter for us when we write it. Now we have 2 times 100 million. Well, 100 million is 10 to the 8th. There's nothing in the 10 millions place, so now we're at the millions place, so plus 5 times 10. The millions place is 10 to the 6th. Going down to the 10,000s place, we have plus 9 times 10 to the 4th. And the reason I know these values of the exponents, it's actually how many things are right before it. So when we look at the 9, we have 1, 2, 3, 4 digits before it, so it's times 10 to the 4th. And then lastly, we can put plus 6. And if you want to, you can put 10 to the, and it's the 0 power. Now, you don't have to put that, though, so let's just cross that out. That was extra. So there's expanded.